Hey there, guys. This video, we're going to be taking a look at Unit 1, Lesson 2, working through the mastery test and the questions that I think are good questions and the ones you should be able to solve versus the ones that go way farther and way deeper than what we did in class. Now, remember, with these problems, these are the problems in the order that they give me. You're not going to have all of the problems, and your problems are probably not going to be in the same order that mine are. So this is kind of to be used as a guide to help you get through it, but it's not going to be an identical match, okay? So looking at this first question, they tell us that each list shows the interior angle measures of a quadrilateral. So hopefully you remember that quadrilateral means a shape that has four sides. So automatically in my head, I'm thinking something that looks like this. So four sides in the shape. And then it says which, and I'm not necessarily assuming that I've got a rectangle or a square or any shape like that. It's just going to be four sides. It says which set of measures describes a quadrilateral that cannot be inscribed inside of a circle. So remember, inscribed inside a circle is a quadrilateral that's been written inside the circle. So we are going to pretend that this is a nice pretty circle, just like you've been pretending that that's a nice quadrilateral. So we had a rule for our quadrilaterals. When they are inscribed inside of a circle, there is a direct relationship between the angles that are opposite of each other. And this is true for both sets. So not just for those two, but also these two right here. Hopefully remember that those two angles are related by being supplementary. So that means that this angle plus this angle right here, whatever their measures are going to add up to be 180 degrees. Also a rule with a quadrilateral that we talked about, but it's been a good while since we talked about it, was all four of the angles inside of a quadrilateral have to add up to be 360 degrees. So 360 is what those all four should add up to. So you've got to figure out which one of these can't be a quadrilateral inscribed a circle. So you've got to check. So I'll do one of them with you, and that way you have 1 out of 3 the chance of getting this guy right. And you'll have one last one you'll have to check. So if I take that 69 plus the 103 plus the 111 plus the 77 and put that in my calculator and add all four of those together, that's going to give me 360 degrees. But we've got to check. That's not enough. We've got to check and make sure that it's an inscribed. We've got enough to say, yes, this could very well be a quadrilateral, but we need to say whether or not it could be inscribed. So that means we have to find out whether or not there are pairs of numbers in there that add up to be 180 degrees. So like what I mean by pairing them up is the 69 and the 77, they are not going to add up to be 180 degrees. So we're not going to want to pick those two to try and pair together. The 103 plus the 111, there's definitely going to be greater than 180. So those aren't going to be good options to pick to try and pair up with another number to try and make 180. So I'm going to pick 69 and 111 degrees and put that in my calculator really quick. 69 plus 111, and that does equal the 180 that we're looking for. So looking at those two angles, they could be angles that are opposite of each other in a quadrilateral. So that works for that pair. So let's try the other pair. So then looking at 103 and 77, if I put those two in my calculator and add them up, those will also give me 180 degrees. So this is a good answer, or a good quadrilateral. That is one that could be inscribed inside of a circle. So what you need to do is you need to go through, try the other three, and see if you find one that either does not add up to be 360 or one that you cannot pair up with anything to be 180 degrees. So with that being said, be careful. Don't assume that if you match it up to something, it's not going to work. So like if I had chosen to match up 69 plus 103, match up those two angles together. Those add up to be 172. I'm not going to automatically stop and say, hey, this is one that cannot work. I would have gone ahead and just double checked it with the 111 to see if I had picked incorrectly. So keep that in mind when you do this one. Looking at number 2. Number 2 is the center of the circumscribed circle of the triangle, or B. Looking at the next one, this one's a good one. So select the correct answer. So quadrilateral ABCD is inscribed in circle P as shown. Which statement has to be true? Which statement has to happen? And so this goes back to that quadrilateral inscribed a circle rule and figuring out which one of those matches the statement for the rule that we have. And don't get stuck on the fact that DC is a diameter. That's not going to change the rule, and that's not going to have anything to do with us solving that. That could be, or coming up with that, finding that answer. That could be anywhere inside that circle, not just there. For whatever reason, that's the way they chose to draw their picture. Looking at 4. 4 is the perpendicular bisectors of triangle BCD intersect the same point as those of triangle BED, or C. 5 is a constructions question. That one is A. Construct the perpendicular bisectors of AB and AC by drawing a line through E and F and another through G and H, or A, if yours match. 6 is P would be the center of the circumscribed circle, and that's A. Taking a look at 7. That's a good question. You guys should be able to do that one without any help from me. Looking at 8, this is a good question. It's got a lot of going on, and it's got a couple layers to it. But this one is the triangle in the diagram, or in the picture, represents a mold that Anna uses to shape her dough before baking. She also has a circular mold whose rim just fits inside the rim of the triangular mold. So basically what that is saying is she's got this shape that she's making, but then she also has a circle that fits just barely inside the tin right there. And so it's asking the radius of the circular mold is approximately. So if we're looking at that circle, and that's our circle right there, and I'm going to take it out so we can see all the numbers and stuff. So there's our circle. That circle has a radius that is DE. And so they want us to find the radius. So if we look, they give us this part right there, that part right there. And if we look, we could look at right here, and that will give us a triangle. And because this one's 90, this one is also 90. So we know these two sides, and we need to know that one. We could use that triangle there, or the one that I used whenever I did this. Whenever I did this the first time, I looked at this one. This one has smaller numbers, so I gravitated to this one. We have a right triangle here. And so we have two sides in our triangle. We need to find that third side. And the rule that we use to find that is Pythagorean's theorem. But keep in mind that if this is our right angle, I'm going to change colors. If this is our right angle right here, if that is our right angle, this is our triangle, and this is the side we're looking for, that this side right here, this guy is our hypotenuse. So whenever you plug in your numbers to a squared plus b squared is equal to c squared, this has to be your c squared, okay? And with this, I believe there's a drop-down menu. Just go go with whichever one is closest. I think whenever you work it out, it'll be a little off from whatever answer they have here. So if you get like 9 point something or 11 point something or 5 point something, but it's not the same number, same like 2 decimal spots that they have here. Don't go with insufficient data. Just pick which one of those match the closest. Okay. All right. Looking at the next one. So select the correct answer from the drop downs. This is one that seems like a lot to start with, but then this is a problem whenever you sit down and you start drawing the pictures, it gets a lot better. So I'll help walk you through that drawing. Go ahead and take a minute, pause the video, try and draw the picture that you think would go with that problem, and then once you get yours drawn, go ahead and push play, and then we'll check and see if we ended up in the same exact space. Okay, so if we take a look, we've got our circle. Point O is the center of our circle. So there's our center. Here's our point O. And that center or that circle passes through points A, B, and C. So I'm going to put those on my circle. So there's my A. Here's my B. And then here's my C. And then it tells me that angle B is a right angle. So I'm going to go and draw this in a little bit different color. So there's my angle B. And so they're telling me that this is a right angle. And this goes back into that rule that I've been talking about in these mastery test videos, reminding you that right angle, if we've got a right angle in a circle, then if we make the third side to make it be a triangle, we are going to end up with a right triangle. So that tells me that it was okay to go ahead and connect AC together to make the third side of that triangle and have it go through O. So then it says the center of the circumscribed circle lies on the segment, and then you have to go through the drop-down box and pick which one of those 3 it would be. And hopefully now that we've got the picture on there, it's super easy to see. And then the longest side of the triangle is equal to the blank of the circle, and I'll let you fill in that blank. And then looking at another possibility that you could have for a question. Again, this one just takes it a little bit farther than I want you guys to work for these right now. So you're looking at the center of the inscribed circle of triangle ABC is point S, and the center of the circumscribed circle of triangle ABC is point P. So there is a difference between the center of an inscribed angle versus a circumscribed circle. Those are not things we discussed in class. I know the lesson did, but I'm going to go ahead and tell you that those are S and P. Right. Well, hopefully this has helped. If you're stuck and you still have some more questions, please email me, or if you are able to, pop in during my virtual office hours time, and we'll walk you through and get you through it. All right, guys, take care.